Hello. Hello. Good afternoon to you all.
Good afternoon, sir.
Yeah, good afternoon. So could you able to see the slides now?
Yes, sir.
Okay, very good. So before I begin today's experiment, that is determination of cohesion or cohesive strength of soil by Vane Shear test. If anybody would like to ask any question regarding this, all you
Good
anybody
afternoon,
wish
sir.
to get clarity. Good afternoon.
Sir, this is Raja. Sir, regarding the last experiment, sir, it was very difficult to find data set for this the experiment that we had to submit before today too. Sir, after finding a lot, sir, they were also in very raw form. Like we had to copy every slide entry from that. Sir, so usually, sir, for certain
Okay.
experiments we do face problems. Like for some, it's easily available the data set. But for sir, this one it was very difficult.
Correct.
Sir, we communicated with almost every friend of the civil, almost every student. Then they said that they got some entries from somewhere. Then we joined different datas. It was very messy, sir.
So it's not messy, but did you ask your seniors because they have already done such a kind of testing? Why did not
Sir,
they could able to provide?
sir, I thought of asking one senior, but then I thought he's at his home place and he will not be having his past year lab manual. So
But see, whether last year or this year, everybody is working only on the email business. So there is no question of hard copy. So
sir,
though they
sir,
submitted
this lab was not
all the results.
this lab was not online last year. Like we started from March. This is in autumn semester.
No, no, I'm talking about your seniors because though they submitted the record in hard copy form,
Yes, sir.
but they were analyzing all the results on soft copy. So they might have saved a copy of all the results.
Oh, okay, sir. That did not cross our mind actually. Like we thought maybe it was on manual. So
see, see, for example, just imagine yourself also.
yes, sir.
Although you are writing the report in soft copy form, but the same supposed to be submitted in hard copy form if you are physically exist in IIT Bhubaneswar. But
Oh,
unfortunately, it was not the case. But your seniors has done, so they prepared all the copies on soft copy, took
yes,
the
sir.
printout and submitted in the hard copy form. So that's what I
Okay,
mean
sir.
to say. Yeah,
Sir,
I
Sure.
also
Sir, on also,
understand.
sir.
Yeah, I also
Uh,
understand. You are true.
yes, sir. Sir, one more confusion about this. The report that you sent us about our lab submissions. One of the lab I
Yeah,
know
yeah.
that I was not able to submit. I had actually told you then, because of my internet connection problems, I was not able to submit that on time. Then you had said me that you will
Okay.
you will look into it because I had after 1 hour of the actual time I had mailed this sir
Yeah.
Manas Chandra sir, but it's still sir, it's showing I have not submitted. And about the not the past one, before that one I had submitted that on time. The it showed me this Google form also that this my report has been submitted, but sir, it's still showing that it has not been submitted.
So it is happened with almost
Okay.
every student, sir. Everyone has got one or two
Yeah, I'm
sort
sir,
of.
coming.
it's a general problem, sir.
So
General problem.
no issue. I'm coming to that point only. See, certainly we did not evaluate means we did not receive it. Otherwise, there is no chance of missing from us. Okay, that never happened because if you look at hard copy form, so we have a bunch of records with us in hard copy form. So, but in soft copy form, there is a possibility of a net disconnectivity or something. What you do is, whomsoever are reporting that they have sent, but the evaluation was not took place. So, what I request is,
Yes, sir.
you just send the screenshot of your email or something of that particular date, whatever the date you are saying, because we have a 1 week stipulated time. So within that 1 week, if you found that you submitted, but we did not receive, we are happy to consider. So it comes under typically the net connectivity problem. So there is no question. Okay.
Sir, also about that one, like the one I told you when my internet was disconnected, that lab that's also
And
not
no,
submitted. Like
no, you might be having a record, na, some, yes, you sent it or something. You just send
yes, sir,
screen
yes, sir.
copy that I sent it. So then we will
Sir,
look
my
into it.
email
No
record I
issue.
have for that.
Yeah, whatever,
That like
whatever
sir,
it
at
is,
that time
whatever
it
that
was
is.
like at the night it was 12 the deadline. I sent it by 3 in the night, like 3 a.m. I have that record of email. I'll
Okay, no
send that to
problem.
sir.
Just share all the, yeah, all the
Sure, sir.
screenshots. No issue. No issue.
Sure, sir. Thank you, sir.
Yeah.
Thanks.
Sir,
Sir,
Okay. Yes, yes. Please tell me. Yeah.
sir, but when we are opening the link now, it's showing that link has expired.
Which link?
We already submitted the lab report, sir, but you didn't evaluate it.
Mm, you must be having some kind of a record, na? You must
Sir, we
be
don't
getting
get
some
any
kind of
recording response. Sir, there is no response email we get, sir.
no email response is not there, but at least there is some kind of a record from your computer.
No, sir,
See,
there
normally
is
when
nothing.
Sir, there is one record about like last edited time, like that can tell you that we had like finished making the report at that time.
yeah,
yes, sir. The
something like that, something
date of that some.
Sure, sir. We will send that
last
last
edited
edit.
one or something. There is some record. See,
Sure,
this
sir.
is the era of artificial intelligence. Whatever you send, nothing can be deleted from your computer or from anywhere.
Okay, sir. Sure, sir.
So we are happy to consider. What? See, if I don't consider what will happen. So we'll be very happy to consider. There is no problem, absolutely. Just send some kind of that, sir. I have this one because we are also responsible to department. Nah. If anybody is asking, uh, see, how did you consider? How did not consider? So if it is a physical, there is no problem. But you are at some point, we are at other point. So at least I will be having some kind of proof that yes, these people are submitted, but because of the internet connectivity problem, they couldn't able to show in time. So therefore, it is considered. That's it.
Sir, but we have submitted through Google Forms. No?
That's what we are tracking. There is some edit option or something that is saved.
No, sir,
Sir,
that
to whom
response
we
is
have
not
to send?
saved.
You can send it to me only. You can send it to Manas Misra or Sangeet Kumar Patra, to anyone, no problem.
Hello, sir.
Yeah,
Sir, this is Shivam here. Sir, yesterday night I
yeah,
mailed
please
you
tell
about.
me.
Yesterday night I mailed you that I have submitted the experiment report of experiment number 4, but it is showing that I haven't submitted. So what should I do now? Means I need to submit it again to you or to
That's
my.
what we are talking about. See,
Yeah. Okay. So
how did you
should I
submit it?
send it again? I submitted it by Google Form, sir.
No, how did so you'll be having some kind of edit option. It might be saved in
Sir,
your edit option that it has been.
Sir, actually, for those links, we can't edit that response so that I can again submit that. So I need to send it to you by the mail or by something else. That's what I mean to say.
No, that is okay. No, what I'm asking is, I just need some kind of a proof that yes, you attempted at that time, but because of the internet connectivity, it was failed.
Sir, so the proof for that is only that the form is showing that I have submitted. That is the proof.
Okay, no, yeah, no issue. You just say with the
And
same thing. How does it matter? No problem.
sir, one more thing. Actually,
Yeah.
told that we can talk to our seniors, and I talked to them, 2, 3 seniors,
Mm,
whomever I know. So they told,
yeah.
particularly, they don't have the data at this time in their laptops. I don't know why. So it's really tough to get the data from actual data from the net. So that will be better if we are getting the data from you. I think, sir.
Let me see it, because your senior supposed to have a kind of a data, because almost half of half of your senior batchmates has conducted the experiment. See, nobody can process the data on hard copy now. So when they have to draw the graph,
I
they're
know
supposed to
3-4
draw.
seniors, so I called him, but they told me that we are not having that. So we can't force someone to give us the data if they are not having.
Yeah. Let me try
So-
it.
So, sir, what could be done for the next lab? Means today's experiment.
Today's experiment, I will talk about that.
Okay,
Today's
sir. So I will.
experiment you will get.
So, sir,
There will be problem only about the UU. Getting a data is bit difficult, I know. But at least I'm very happy that couple of few people are attempted to get the data by various, but majority of the people are still not responsive. So indicating that either they are not attempted or they don't want to do it. Okay, but I'm very happy that at least you people are attempting and saying that yeah, it's not possible. Means I also aware it's not possible. So I'm aware, but I want to listen from you. What is the possibility? What is not possibility?
Sir, one more thing, what I may want to means mention here,
Yeah.
that the evaluation file we got yesterday, it is showing
Yes.
some copy that we have copied from someone. It's showing that there is the blank
Yeah.
option that sir, what if the problem was that it was very on this point we already discussed. So it was very difficult to get the many kind of data from the internet. So the readings can be saved at that time, but it shows
Okay.
that
See,
in the
let
earlier.
me explain you since you are asking.
Yes,
Yeah,
sir.
at least there was a big debate about the same point at institute level also. What happened is you can use the same data. Nobody says that you don't use the same data. But when you yourself, the way of inference or the way of interpretation is always different. So there is no commonality between any two students. But it is very unfortunate that majority of the reports that we have seen, it is like a simple copy and paste. Whatever one student, for example, whatever you have done, so with your hard work, so
Yes.
you might just for the sake of sharing that, but he not only copied as it is, he did not put any kind of effort. So
Sir,
that's
we are
what is
very
bothering
sorry.
us. We don't have
Sir, we
any
are very sorry.
reluctance. No, I'm not saying you don't share the data. You share the data, but the thing is, say every individual has to put their own effort. That's what is the entire intention of taking all this laboratory. Because being a difficulty in getting the right data, you can share the data. I don't have any difficulty and I don't have any complaint
Sir,
also. When you have shared
may I
the data, at least he has. Yeah, tell
hello.
me.
Yes, sir.
Yeah,
May I
yes.
mention the actual reasons? Hello.
Yeah, please.
Sir, can you hear me? I'm not getting.
Yeah, I'm able to hear you.
Sir, the actual reason is this, that till the end of the end time we were searching the data, and most of the time out for that. So sometimes we are very sorry on this point that if somebody is copying, but it's our pleasure if we'll get the data and we'll write the report by ourselves. So sir, it will be.
That's what I'm saying. See, I appreciate a lot. At least, see, by way of asking, I can understand how much effort you put. Okay, so it will be reflected always. When people has put a lot of hard work, it will be reflected. But it is very unfortunate that, see, being your classmate or being your friend, when you share the data with someone, take the data, but he should do his own analysis and he should write his own comment. Okay, he should not copy and paste the same comment as it is or same inference as it is. So that's what is the concern. Because when 100 people are thinking, we should get 100 different comments. Not one comment is copied by several people.
Sir,
Yeah.
sir, we have submitted our records through Google Forms. Sir. Now, when we open that form, there is no edit options.
No, there is no edit option. I don't want any edit option.
Like
But when you have submitted, you might.
now, but at that time we don't take any screenshot or anything. Sir.
No,
Like
yeah, you might not have taken, you might not have thought of that this situation arises also, but there will be some kind of a sent record or some kind of a record might be existing. See, normally, whenever we fill any Google form, because it is not that you are only filling, we also do the same Google form filling. So we get the confirmation email. We always get the confirmation email.
Excuse me, sir.
From the Google form.
That there are options in many
Yeah.
Google Forms to send the response, but
Excuse me,
it
sir.
was not in this Google Form, sir. So it should be done by institute level only. To send me to send us some.
No. See, the moment you submit any Google form, you're supposed to get the reply from the email, the Gmail.
Yeah, sir. Actually, that
It is
option has to be enabled
default.
by you.
That option, but that is a default option. There was no enability or something.
Hello.
Yeah.
Sir, actually, that option of sending us the report of what we have sent you, that should be enabled by you. Actually,
Yeah,
when you make the Google form, there is an option to send the read receipts. Actually, send the Sir, I'm being constantly removed. I don't know why.
So many of us are being removed, sir.
Yeah, I have to make a small exercise. See, this is very pathetic. Yeah, so now you tell me. Yes.
So actually, that option has to be enabled by you, so we don't have any kind of proof regarding that.
So that means
Actually,
since
we
beginning
didn't
of
get any receipt of that we have
since
sent.
beginning.
Actually, yes, sir.
Since beginning.
Yes, sir. Since beginning.
Acha. Okay, let me see it. Then. Okay. So anyhow, we have a record of all the emails. So then we will definitely look into it.
Okay. Or can sir also send once more? In a separate mail.
Not in a separate mail. So let me evaluate even today's experiment also. Then after this is the 13th experiment. So after 13th is also over. Then again, we will share the final one. There we can find the inclusions of omitted ones, which you complained officially through email.
Okay, sir. And sir,
Hello, sir.
in sixth, and sir, in the sixth experiment, actually, I submitted a compiled report containing both 6A and 6B in the single report in both the links. And it is not showing that I have submitted 6B. It is only showing that I have submitted 6A.
Probably they might have missed it because normally they will consider only one. Just write an email. You have written already email, na?
Yes, sir. Yes, sir. I have sent you.
Okay.
Thank you, sir.
Yeah.
Sir, actually, the problem is I have mailed me and my some friends mailed the report to like Manas sir. Okay. So we have not filled the Google form, so it was not evaluated. So can we send that email to you with CC in Manas?
No, but why did not to submit it in time?
Sir, actually the thing was like we submitted that report by mail. Okay, sir. Actually,
But
we have not
do we have a
read that. Yes, sir, we have the proof of sending that mail. Okay.
just that send the proof also, then don't no problem.
Okay, sir. Okay, thank you, sir.
Sir,
Yeah.
sir, the weightage of the report submission is of 50%, no, sir. Like we are be taking 60%, sir.
Yeah.
So, like it is taken all the 12 experiments or any best out of the 10 experiments, it will be of
No.
helpful, sir.
No. Because that is against the regulations of institute. Na? As per the institute regulations, so it is like 60%, 40%. And there is no provision such that we have to take only the best out of one. No, nothing like that. But what prompted you to ask this question? I'm wondering. Okay, so any other questions? Hello?
Hello, sir.
Yeah.
Sir, except the file, we don't have any proof that we have submitted because it is showing while I opened this link, the form experiment number 4 is no longer accepting responses. Try contacting the owner of the form if you think this is mistake. Sir, so how can we prove it
No,
that we have submitted?
that is true.
So, sir, how can we prove it?
Let me see it. Because I just tried to inquire from someone the answer. So no
Sir,
issue.
if you want,
Because
can
I was
send
under
it.
the impression
Just
that the moment you are submitting, you are getting an email reply of confirmation. Because this is normally whenever I submitted a Google form, so I used to get a confirmation email from Gmail.
sir, but there was
Sir,
the
the
option.
time history will be there, sir. Like at what time it was submitted.
Is it there?
Hello, sir. Sir, we can see the date and last date and time of the edited version, sir.
Yes.
So we can take the
That's it.
picture
That's
of
what
the.
is required. Not we don't require more
Is it
than
enough?
that.
Is it enough, sir?
Yeah, that's good enough.
Sir, which
Nothing
mail,
more.
sir, we have to submit
Date
that proof?
and time that. You can send it to that Manas Mishra and Sangeet Kumar Patra. I will talk to them and we will combinedly evaluate. No problem.
Okay, sir.
Okay, good. You got it. You gave the answer to everyone. Fantastic. Good. So can I start the today's experiment? Anybody still want to ask any question? Yeah.
Sir, what is pore pressure parameter, sir?
Pore pressure parameter means, see, for example, you take one cylinder, okay, one steel cylinder, Inside it keeps some soil, but under fully saturated condition, and on top of the soil, and make sure that the cylinder doesn't have any holes initially. Okay, and on top of the soil, you try to apply axial pressure. When you apply the pressure is shared between the water particle, water molecules, and soil particle. Okay, so the amount of the pressure borne by water molecule is called as a pore pressure.
Sir,
You
the
got it now?
Sir, and parameter pore pressure.
Parameter means there are two parameters for pore pressure. One is A, next is B. So a parameter B, actually what happens is when you conduct any, this is valid for the triaxial testing. When you conduct a triaxial testing, in fact, I explained during the unconsolidated undrained test also, there are two stages in all the triaxial testing system. The first stage is called as a consolidation and followed by shearing stage. So the pore pressure that is developing during the consolidation stage is referred to as B parameter, while the pore pressure which is developing during the shearing stage is called as a parameter A. So the parameter B is linked to confining pressure. Parameter A is linked to application of deviatoric stress. But there is a relationship between A and B with confining pressure and axial load also, axial stress. You got the answer? More clarification is required.
Also, sir, some questions are difficult to answer in Viva, sir, as we have not covered this in our theory class till now.
Yes, sir, for this experiment.
Yeah, no problem, but at least see. So you are coming forward to ask the questions, or at least you are Googling, you are searching in the web, whether you are getting the right answer or not, but this is what is required. So for this purpose, normally so we give all the questions. So if you strictly confine to only whatever has been taught or explained in the experiment, so then you won't learn any new things. So there should be some linkage, all these are interlinked to that particular experiment.
No,
So
sir,
any
there is
other
one
question?
also question like that related to shear strength parameters and other things. Means we haven't, we don't know much about that one, sir.
No, but I
We can get the
explained.
answer from.
Oh, I explained already, na? Because during the UCS test, I explained what are the shear strength parameters. During the UU test also, I repeated what are the shear strength parameters. In fact, today also, I'm going to explain about the same thing. I'll be explained. Means, what is your question? Then I can say whether I have answered or not.
No, sir, because some questions are from the next experiment, like draw the graph of CU test, CD test, like that, sir. Means like we haven't performed a CD test and CU test. And from the Google, sir, we are means if we perform the same test on same type of soil, means we are not getting that much data, sir. Means we are getting CU graph, CD graph, and UU graph, but I don't know whether they are performed on same soil or different soil, so we can't compare and make the difference between them.
No, may not be on same soil, but whatever the soil it is, the typical trend is same. Means when I say CD test, The trend of a CD test is permanent, whether it is regardless of the soil type. Similarly, when you talk about the CU, the kind of a response that you will get, that is Mohr-Coulomb envelope, is same regardless of the soil type. Because if that is not the case, then I would have explained about. So
No,
you
no,
draw
sir.
this
I am
graph
asking
for
about stress strain curve. Only stress strain.
even stress strain also. Stress strain is same. In fact, stress strain is regardless of any kind of a material. It is same for. Oh, acha, that one. Oh, that one means what I'm asking is that I asked based on my explanation only. See, basically, when you talk about UCS, UU, CU, and C, in all of these tests, what you will get is stress strain graph followed by Mohr-Coulomb failure envelope. My simple question is, suppose on the same soil you conducted UCS and UU, so which soil will exhibit more strength? Suppose if you superimpose the stress versus strain diagram of UCS and UU, which one falls above and which one falls below? That's it. That's what is my.
Sir, but we don't know about CU test now, sir. Means we haven't performed it. So then how can we superimpose them?
It is based on your simple understanding. Understanding means that I appraised also. See, for example, in UCS, what is happening? So there was no drainage. It is undrained condition, but there was no confining pressure also. In UU, I explained there was no drainage, but there is a confining pressure. So it is obvious when you closely look into the data, when there is a confining pressure, there is a more stress taking up. Suppose if we superimpose the stress strain graph, so in case of UCS, as there was no confining pressure, that is sigma 3 is 0, so it gives one maximum shear stress. Okay, but when you provide the confining pressure, that is sigma 3, then obviously the maximum stress increases. And that is for UU. Now suppose in case of the CU, they are expelling the water. That means the strength of the soil increases. And in case of the drained also, you are further expelling the water. So therefore the strength increases. So this is based on the fundamental understanding. What happens to the strength when you expel the water? That's it.
Sir, it is necessary that if expelsion of water will increase the strength.
It has to. It has to. Just imagine yourself. See, when you get dehydrated, what happens to your skin and flesh? Will it become a stiff or will it become a soft? See, our body also, there is a constant blood circulation. So that is the reason we feel always our flesh is very soft. But just imagine if you remove the blood, then what happens to your skin, thick skin? Will it be soft or will it be stiff?
Stiff, sir.
Yeah. So what do you mean by stiff? So more strength. So in case of the soil also, it is same. If you more and more dry the soil sample, there is a more and more the strength resistance, or it offers more and more resistance to applied axial stress.
Okay.
Good. Good question you are asking. Very good. So any other questions? Okay. So let me take up the today's experiment that is called as a Vane shear test. Today we will talk about determining the one of the shear strength parameter, that is cohesion of a soil by Vane shear test. So this IS 27, this IS code covers about the shear strength of a soil, that is a cohesion. So by adopting Vane shear test. So let me also make you distinguish the three variety of triaxial testing that we were discussing about. So this was I'm explaining. If you take at any point Z from the ground surface, at that point, if you take any small soil element and on which the stresses acting are sigma Z, which is nothing but gamma times of a Z. So this is what I was keep on explaining since we are dealing with the UCS test, unconfined compressive strength. So if you take a small element from a depth of Z below the ground, the stresses that will act on that particular element are the vertical, that is sigma V, lateral, that is sigma H, shear, that is tau, then the pressure because of the water, that is pore water pressure. When we explained about unconfined compressive strength, we have simplified this stress strain diagram such that we have removed sigma H. We assumed there was no development of the pore water pressure because the test is very quick, and there was no shear stress acting on the sample. So therefore, we applied only sigma V until the sample is failing under shearing condition. So that is called as a unconfined compressive strength test, where sigma 3 is 0. So followed by UCS, we were also discussing about unconsolidated undrained test. Herein, there is an improvement over the UCS test. That improvement, when we initially assumed sigma 3 is 0, but in case of the unconsolidated undrained test, we applied a constant value of sigma 3. Then we increased the sigma D until the sample has failed under shearing condition. So in both of these cases, our intention was to determine the shear strength parameters, that is cohesion and angle of internal friction of clayey soil. Now today we will see how to determine the cohesion or the shear strength parameters, but by adapting to different technique that is called as a Vane shear technique. So there is a device called as a vane. Since we are determining the shear strength of the soil, so therefore the shear term has been involved. So we use vane as shown in this diagram. So this is a vane with the 4 blades, and this vane is inserted into the soil sample and rotated by applying the torque T. So when a torque is applied, so these blades try to shear the soil sample in a cylindrical way in a rotational mode. So when these blades are shearing the soil sample, so how much resistance is offered by the soil sample, that is called as a shear strength of a soil. So if you compare the vane shear with the UCS and UU, in UCS and UU, we applied the axial load confining pressure so as the soil sample to fail under shearing condition. But that is an indirect way. But the best direct way is literally shear the soil sample with the help of a blades. So the vane shear is one of the most widely used field technique to determine the in situ shear strength of a soil. So this is the schematic diagram of a vane blade or vane shear apparatus. So here in this case, there are 4 blades, but if you look at any literature, you may be finding 2 blades, 3 blades, 4 blades, or more than 4 blades. So it doesn't matter. Okay, but if you look at carefully, when you apply the torque to shear the soil sample, it rotates in a cylindrical way and cuts the soil sample in a cylindrical way. If you look at carefully, so each blade or each side is offered resistance by the soil sample. So this resistance is measured in the form of a cohesion and angle of internal friction. But the vane shear test usually will give you only the cohesion soil sample. It will not give you the angle of internal friction. This is an empirical equation which is relating applied torque with the cohesion value of the soil sample. along with other parameters, like because we are using the Vane, so this Vane shear is made for a particular geometry, that is the diameter d and height h. So therefore, if you look at this formula, it accounts for almost all the amount of the torque applied, the resistance offered by the soil, that is Cu, the diameter of the vane d, and height of the vane 6, height of the vane, that is h. So this formula you can also derive, so based on the simple understanding of simple geometry. So this is how the soil offers resistance. Suppose if you take the free body diagram of each blade, so all along the periphery of each blade side, the soil offers. So the three sides get the three sides cut the soil sample and thereby measure the shear strength of the soil, that is in the form of a Cu. Now here in this case also, what we will get is undrained cohesion. Why, when you conduct any vane shear test, here in this case also, we will not allow any water to expel out from the soil sample. So I explained clearly when I explained about the UU, what is the difference between a drained and undrained condition. So undrained condition means we will not allow the water to get out from the soil sample. So it is strictly confined. That is called as a undrained condition. So in undrained condition, the water molecules also weigh some amount. So that is, but that is a what is the basic meaning of the drained condition. In case of the drained condition, so as the water molecules cannot able to take the load, so because of the application of the load, so they will go away. So with the equivalent property, that is permeable. So the vane shear test can be conducted both in the laboratory as well as in the field. So both the experiments are very prevalent, but the field test is more prevalent and widely used rather than the laboratory test. So these schematic diagrams demonstrate how the vane shear test is will be conducted in the field. So this is a vane shear mission. As you can see, this is the vane shear, so driven into the ground. So this is the vane shear. This is the larger picture. So this is the vane, and it will be driven into the ground. So at whatever the location or the depth you want to determine the cohesion, at whatever the depth you want to determine the cohesion, so drive the vane shear up to that particular depth, then determine the shear strength of the soil at that particular location. As you can see, so in the left side diagram, so this is a driving of a vane. So this is insertion of vane rod, insertion, then rotating, so then determining the shear strength. So the fundamental principle is remained same whether you conduct vane shear test in the laboratory or in the field. The equations are remain same. And this is the schematic which is showing how the vane shear test is conducted in the laboratory. So this is the small device. So this is schematic of a vane shear. So there is a provision for applying the torque. So as you can see, there is a rotating arm with which the torque is applied onto the blades. So these are the blades. Blades are made for a particular geometry. The geometry is usually the aspect ratio of, if the diameter is d, the length is supposed to be. You can also understanding when you draw the free body diagram. So when you apply a torque, how this torque is converted into the equivalent shear strength of the soil. So this is another schematic diagram. So this equipment as a provision to lift or lower the vane shear blade. So this is the vane blade. As you can see in this bottom right side diagrams of A and B. So here the vane is at the uppermost position. So here you can see the vane is lowered into the soil. So in a nutshell, so we can understand that the vane shear test can be conducted in the field as well as in the laboratory. The aim of this experiment is to determine the shear strength or cohesion of a clayey soil, and it is the method of measuring the undrained shear strength of a cohesive soil. undrained because the test is very quick. Within that time, no water will be allowed to escape from the soil sample. So that's why it is called as a undrained. The test is most suitable for clayey soil. So this test is not at all suitable for the sandy soil. So it is exclusively valid for the fine grained soils. So it is a very cheaper and quick method. The test can be conducted in the laboratory and in the field. So the laboratory Vane shear test is useful for soils having a low shear strength, that is 0.3 kg per centimeter square, for which the triaxial or unconfined compressive test cannot be performed. So one of the particular usefulness of the Vane shear test is if the soils are too soft, where it is practically impossible to collect the soils from the laboratory and conduct any kind of a triaxial testing. So in those situations, the Vane shear test is conducted. Second thing, just imagine it is practically always not possible to collect soil sample from the field. Just imagine you want to collect a soft clay. See, this soft clay has a high friction. So when you are trying to grab a soil sample, say from the 10-meter, if it is a too soft, it will easily slip. We never could able to grab any kind of the soil clay sample, especially if it is a soft clay, from larger depths. So in those situations, the Vane shear is the most ideal test to determine the shear strength of the soil. So that is, these are the situations. There is another situation. We normally, when we deal with the soil, we always remold the soil, and we also know the soil is under undisturbed condition. Undisturbed means the soil exists in the field as it is. That is called as undisturbed. Just imagine collecting the same soil from the field to the laboratory, then it is in pulverized condition. So that is called a disturbed condition. So we disturb the soil sample, that is the disturbed soil sample. Undisturbed means it is in the intact ground. Now there is something called as a sensitivity of a soil. So this sensitivity is defined as for a same soil, how much strength exhibited by it when it is an undisturbed to when it is in a disturbed state. So this is called as a sensitivity. So for better explanation, what I have done is, so you look at the bottom right side figure. So this is the cylindrical soil sample, same soil, but when it is in remolded state or when it is in dry state, it could able to bear huge amount of a load, huge amount of a load. But same clay, when you increase the water, it will be turned into the slurry. So, but if you measure the strength of this cylindrical sample and this slurry, so both will have a different shear strength parameters. Or see, or other way around of understanding this one is, initially I have a slurry, I determined some strength, and I allowed for some time to stand or under undisturbed condition. And after 24 hours of undisturbed condition, I again determine the strength of that particular soil. So if you compare the strength of the slurry, which is prepared right immediately, the strength was determined right immediately, the conversion of the slurry. And the same slurry was allowed for undisturbed condition for about 24 to 48 hours. So the strength, if you compare the strength right immediately preparation of the slurry and the strength after 24 hours of undisturbed condition, you can see huge difference. That is called as a sensitivity. That is called as a sensitivity. How much strength exhibited by the soil under undisturbed condition upon how much strength exhibited by the soil upon disturbance. So there is some classification also which has been given based on the sensitivity that we can see in this picture. And this diagram also make you understand how the shear strength decreases and gains with respect to time. depending upon undisturbed or disturbed condition. So initially we have taken the undisturbed soil, where the strength of the undisturbed soil is very high. The moment you collect it, it is in a pulverized condition. All the particles are individual particles. That is in a particulate condition. Now what you have done, this remounded soil is converted into cylinder. When you have converted, that process is called as a remolding. That process is called as a remolding. So because of the remolding process, the shear strength got increased. But when you shear it, then shear strength gets decreased. Or when you remold it, then shear strength gets decreased. So this is the fundamental philosophy of variation of shear strength with distance and without distance. As you can understand, when you undisturbed. So the applications of the Vane shear test are enormous. So the Vane shear test may be required.
Sir, can you
So
once,
when you plan
once
to
again explain sensitivity, sir, with example?
okay, sensitivity with example. So here, just imagine you have given a clay soil sample collected from the field. So when you have collected from the field, you try to measure the strength of it. Okay. Or okay. Instead of that one, but please. Just imagine. Okay. So let me make a relevance between the formula that is strength of undisturbed by strength of disturbed. You can see here. Try to make a link between the ST versus this graph. When the sample is in undisturbed condition, the shear strength is high. That is called as undisturbed. The numerator is, but when the same soil sample is remolded, that is called as a disturbance. See how much is decrease in the shear strength. So if you take the ratio of this value divided by this value,
how we are
is called
defining
as a
undisturbed soil?
sensitivity.
So means how we are defining the disturbed means when we'll say the soil is disturbed.
Just pulverize it.
Pulverizing. Sir, what is mean by pulverizing?
Either you can do simple pulverization. Yeah.
Sir, and for undisturbed strength, we have to go in the field, sir.
Suppose if you can't able to understand, if you okay, if you can't able to understand that one, now let me give another example. Now you take the clay, convert the clay into slurry. As shown in this book. So the moment you have converted the clay into slurry, you try to determine its value. Okay, so what you are getting is the strength at undisturbed soil into slurry. You caused a disturbance. Okay, now this slurry you allow it under undisturbed condition for 24 to 48 hours. Then after 48 hours, you need to determine the strength. Okay, what you can see is obviously there is improvement in the strength when it is at initial slurry condition and it is after 48 hours. That is called as a sensitivity.
Okay, sir. Means disturbed don't means compaction. We can compact and prepare a sample in laboratory. Then it is not made. It does not mean it is disturbed.
No, even that one also valid. Even that can also valid. But in the case,
sir, but then sometimes we can get the disturbed strength greater than undisturbed strength. It may possible or not, sir.
No, that never happens. That never happens. The reason is that undisturbed means this formation is done by the nature. So nature always does at its and when it is done, the nature is to hundreds and thousands of years to come to that particular. But back the soil sample, you compact in half an hour or 1 hour. So this half an hour, 1 hour process does not hundreds and thousands of years. So you should never expect the half an hour strength with thousands of years of this. You can never achieve the same density. So easily there are a few applications of Vane shear. So we conduct normally Vane shear for the applications of foundation design, highways, airfields, or slope stability, lateral earth pressure, undrained cohesion, soft soils. So these are the different applications in foundation engineering. So in all these situations, we can go for conducting the Vane shear test. And in fact, the Vane shear test can be conducted as a function of the, we can get the complete profile of a the cohesion when you conduct the Vane shear. You can completely get the profile as a function of depth. So these are the different apparatus for Vane shear test. So this is complete mission. So this is the vane or the blade, and this is sample holder where the sample is compacted or just filled. And this is how the Vane shear test is conducted. This is simple schematic of the same device. So different parts: Vane shear apparatus, then specimen container. This is the specimen container for moisture content determination. So this part you know already, and balance. The best procedure is first you take the container, because this container is small one, as you can see. So it is hardly 35 millimeter diameter and 70 to 80 millimeter height. So that is the geometry of this container. So since usually the Vane shear test is conducted in the top soils, so you take any clay soil sample. You take any clay soil sample and prepare it for a particular moisture content and fill this container. So this is a very simple procedure. Simple filling of the moisture soil into the container. That's it. So then place the specimen container on the base of the Vane shear apparatus. So this is the base of the base pedestal of the Vane shear. Put the container with the soil. So then lower the Vane shear into the soil sample. So this is the schematic diagram demonstrating what should be the minimum lowering depth. So when you lower the Vane shear into the soil sample, so this is the soil sample and these are the Vane blades. So you have to at least minimum ensure that there is, after insertion of the Vane, there is at least a gap of 10 millimeter from top of the Vane blade to the top of the soil sample. So that is the minimum requirement. If you keep more, that is acceptable, but minimum requirement is there should be a gap of minimum 10 millimeter between top of the soil and top of the blade. So once it is inserted, so this is another schematic demonstrating the position of the Vane and topmost position of the soil sample. So the Vane shear will not only be conducted on a soil sample which has been filled in our container, which is for a specific geometry, but you can also conduct Vane shear test on any randomly on any other soil sample, as we can see. So in the left side, our most picture, because it depends upon your necessity. So this is a torque ring. So you have
Excuse
to
me, sir.
down the initial reading.
Sir.
Yeah.
Sir, we can't see the slide you have changed. The first slide only is visible, sir.
Able to see now the schedule.
So your voice is also not clear.
Oh, my voice is also not clear. Okay. A minute. So then I'll wait for a minute. Is it okay now?
Sir, the slide has not changed.
Which slide are you seeing?
Sir, that there is aim on that slide.
Oh, goodness. Still you are aim only. Now you will be able to see.
No, sir.
Still not.
Very slow. 10 minutes class.
Yeah. Can you please confirm me? Are you able to see the slide of apparatus?
Yes.
Oh, okay, very good. So these are the apparatus required for conducting the Vane shear test. So this is the complete setup of the Vane shear. This is schematic of the same Vane shear apparatus, and this is the sample holder, and this is the Vane blade. So these are this is a small device. So there are only two parts. One is the soil sample holder, and there is a machine for lowering and lifting the Vane shear. So first, what we need to do is we have to take the clay soil sample, and that need to be filled in the container. So this container has a typical diameter of 35 millimeter and height of 76 millimeter, or it can be slightly larger also, but this is the typical geometry. So the clay sample, usually when you take any clay soil sample, the Vane shear test is conducted on relatively soft soils. So therefore the moisture content of the clay sample shall be relatively high. If it is Vane shear test is not valid on the compacted soil samples, fully compacted soil samples. So that's why if it is compacted soil sample in the field or in the laboratory, so it is suggested to avoid conducting Vane shear. So we have to take the clay sample with large moisture content. So that is the requirement. So take the clay, add sufficient water, make it something like a paste, and fill it in the container. So that the sample preparation is over. No compaction, nothing. So then,
Sir, the shear strength
once,
depends on water content.
yes. So that is the reason why, that's what I'm going to say. So once the sample and place the sample on the pedestal. So this is the base pedestal of the Vane shear apparatus. So since you are asking the question, so usually the shear strength of the soil depends upon several factors, but one of the factors is the moisture content. So that's why though we normally talk about the clay soil samples, but there are clays and there are soft clays. Usually the soft clay shear strength is less than 100 kilopascals. So the clay, any clay which is exhibiting a shear strength of less than 100 kilopascal, or even in fact much less, in fact 50 kilopascals, it is called as a soft clays. Soft clays means they could able to hold significant amount of water, which is usually higher than the 100%. So because of the more water, there was no strength at all. This is one of the reasons. Usually the Vane shear test is conducted for varying moisture contents, but all the shear strength typically ranges from, suppose if you want to determine the shear strength as low as say 5 kilopascals or 10 kilopascals. So these low shear strength is practically not possible to determine either by UCS test or by UU test or CU or CD test. So in those circumstances, the only choice with you is to go for the Vane shear. So Vane shear test is especially useful if you want to determine the shear strength as a function of the moisture content, and especially when it is much low, say below 50 kilopascals or below 100 kilopascals. But don't constrain to only 100 kilopascals, that Sir has told. No. So in the literature, you may find even higher values also, but the soil has to be soft such that when you apply the torque, the blades has to cut the soil sample. They have to shear the soil sample. Then you will get the cohesion value. If the blades unable to cut the soil sample, then the experiment is literally failed. You need to discard it. So this picture depicts you the lowering or insertion of the blade into the soil sample. But there is some norm. As per the procedure, you need to maintain at least a gap of 10 millimeter between the top of the soil sample to the top of the blade. Top of the blade. That is the minimum requirement. But if you have a chance, you are advised to go for even little deeper. So this is a elaborated diagram. So showing you the top of the soil sample and the blade position. So as I told, usually the Vane shear test is conducted by filling the soil sample in a small cylindrical mold whose geometry is 35 by 70. But it doesn't mean that the shear test has to be conducted only on this small soil sample. In fact, you can also take a bit larger soil sample depending upon your requirement. So there is no limitation as such. Now, when you talk about any Vane shear test, so the stress is applied in the form of a torque in a cylindrical form. Torque means cylindrical form. So this is the simple schematic which is connected to the scale and with the Vane shear. So this is how it. So therefore, you need to take the initial reading of the torque that is going to be applied. So this is in the form of a angles. So this angle is the rotation is measured in the form of a angles or angle of twist. Typically, angle of a twist. So to measure the angle of twist, we need to record the initial reading and the final reading. Initial reading and final reading. So often it may be more than one circle also. So you need to note down. So even how many number of circles. Then the whole angle of twist is further converted into equivalent torque. Now, when you apply the angle of twist, so this has to be transferred to the blades. So in between, there exists a spring. So this spring facilitates the transfer of torque from the spindle to the vane blade. So therefore, the amount of the application of the torque highly depends upon the spring constant. So therefore, you need to note down initially what is the spring constant. Where shall I show the spring constant? Yeah, as you can see in this picture, this is the spring and this is the rotating spindle. So when you rotate this spindle, so this initially triggers this spring, and from there, so it transfers the applied torque as a force to the Vane shear. So that means the amount of applied load depended on the spring constant. So at the initial stage, you need to note down what is the initial angle of a twist, what is the spring constant. Usually the spring constant is a constant value. So note down the initial angle of a twist, then switch on the machine, then apply the torque as you can see. So this free body diagram demonstrates you how much amount of load applied directly onto the torque. So this is the arm. So with a lever arm of A and the load P is the torque P is applied. So with the angle of the twist. So you know the arm distance, you know the angle of twist, uh, then you can convert these two into the amount of the load applied. So usually the shearing range should be rotated at an uniform rate of say 0.1 angle per second until the specimen fails. So this is how the torque is applied. So you need to apply the torque until the entire sample is completely sheared in the cylindrical direction. The cylindrical direction. So you can say this is the final reading. So this is the initial reading. This is the final reading. So note down the initial and final reading. So then calculate the amount of the load applied. So now I know the amount of the torque applied in the form of angle of twist. So based on the angle of twist, I can, and with the help of the spring constant, I can calculate the torque. I know the diameter of the vane and I know the height of the vane. So therefore I can able to calculate the undrained cohesion. So these are the different values. As you can see in this table, the initial reading is 196, final reading is 188, differential reading is 8, spring constant is 4.98 kg centimeter, and based on this one, you converted into torque, which is 0.22 kg per centimeter. Then once torque is known, I know the D, I know the H, simply calculate the C. Calculate the C. Okay. So this example is about a Vane shear test conducted in the laboratory. Now the same test as I explained you can also be conducted in the field. So when you conduct the Vane shear, so this is the kind of a profile that normally you will get it. The Vane shear strength or the shear strength of the soil is measured as a function of depth at different depth. Say 1.7 meter, then 2.5 meter, then 3.5 meter, 4.5 meter at different intervals of time, we can measure the Vane shear strength. So then ultimately, whatever the value
Sir,
you are
what
getting,
is that
so report.
before treatment and after?
So these I have taken from the net only. That means here what they have done is they have stabilized the soil. So before treatment means the raw condition or in situ soil and it has been stabilized with some chemical, and after stabilization, how much is the improvement in strength? Okay. So as I was explaining, typically the shear strength is less than 100 kilopascals. As you can see, the shear strength is very low. 5 kilopascals, 10 kilopascals, 20, 30, 40. It's less than even 50 kilopascals. Then report the value of the cohesive strength. That's it. Very simple. And these are the review questions.
Sir, actually, so in that shear strength, we have not included pore water pressure, right, sir?
Here no. That is why it's called as an undrained test. Vane shear test is an undrained test.
Sir,
Yeah.
sir, how it is dependent on water content, sir? It is increasing or decreasing, sir? What is happening?
See, say for example, you take a dry clay. Okay, you determine the strength. You will get some X value. Okay, so then you keep on adding the water. What happens? So the clay particles has an affinity to absorb the water. They hold the water literally because of the electrochemical forces, or what you has been told is diffused double layer. So when clay particles hold the water, they form diffused double layer. So just imagine when there is a diffused double layer, and on the diffused double layer, so when you are conducting the strength test, what happens? So this diffused double layer will act as a slippery. That's why in all clay soils, they are highly slippery. This slippery is not because of the clay particles. This slippery is slippage between the water molecules. Why the same slippage is not happen in case of the sand? In case of the sand, it will never happen. But you can see only typical in case of the clay. So that's because in case of the clay, because of the diffused double layer, each particle is individual. However, they have an interaction with the other clay particle, but only by means of diffused double layer. That means literally a water molecule is connected with another water molecule. Though with the naked eye, we can't able to see anything, but this is the fact. And what happens when you put your leg on a clay soil sample? It slips. The slipping means the slippage of the water, not the clay part. Okay. Now, more is the water, more is the separation between the clay particle, and least is the strength. Okay, I'm not talking about the compaction or something, but this is simple.
Sir,
yeah.
Sir, in field, the confining pressure depends on what things, sir?
The confining pressure depends upon the overburden pressure. There is a relationship between confining pressure and overburden pressure, which is nothing, which is called as a coefficient of earth pressure. There is something called as a K, which is defined
It
as
also varies with
sigma.
soil type, no, sir? Soil type and how much the soil has expanded, length, breadth. Does it depend?
No, it won't depend. Fortunately, it won't depend. If that is the case, then there would be another complexity in soil mechanics. and regarding the strength also, I can correlate this with your plasticity chart. Just recall yourself what we have done. We conducted a Atterberg limits test on clay soil sample. So initially we have taken a clay soil. We determined the shrinkage limit. Then we have keep on added the water. Then we achieved the plastic state. Then upon further addition of the water, we reached the liquid state. Okay. So what was happening there? The volume of the solids remains constant, but only the water volume is increasing. So at the shrinkage limit, the soil is very stiff and high strength. But the same soil, with the addition of the water, it turned into a slurry with least strength. So suppose if you understand the mechanism, how the strength is decreasing, because Vs, the volume of the solids remains same, the only separation that is causing is the volume of the water that you are increasing. Yes, please. Any other questions? There is some question. Tanjeer Ahmad Siddiqui. If we apply confining pressure, then it is undrained test. Is this statement true? No, this statement is not true. Undrained means you are not allowing the water to expel out from the soil sample. That's it. Or the very crude way of understanding is you have almost 5+ liters of blood in your body. So just imagine if you puncture at one place and if you remove the blood, then that is called as a draining condition, which otherwise the whatever inside is there, it is always undrained condition. That's why your blood pressure is always constant of 80 to 120 reading, 120 mm of mercury. The moment you puncture your body and you remove the water and measure your blood pressure, will it remain same? No. As you drain, so you are removing the excess pore water pressure. That is called as a drain condition. So yeah, so let me show the Vane shear test video. So this is the video of the Vane. So these are the apparatus, the Vane shear machine, and this is sample holder. So these are the speeds. So sample, so that is sorry. So then
Sir?
let us talk about the test. So this is sample preparation. You can see. So he is preparing almost paste. It's not a compacted one. So this almost that happen. So he is filling the paste in cylinder. So just so that the slurry spreads uniformly with no air entrapment inside the soil sample. So now the sample is ready. So just aware that constant. It starts with the 2 3 centimeter. So is set a particular value. Set it for a 0, or you can set it for any particular. So now take the container and the base particle of container. Now I know that at the up, next is at the low one. One will be constant, one will be rotated during the rotation. Is motorized and top is right. You can see there is a separation now. So that separation indicates that the sample has failed. So then lift the vane. So remove the sample. So he is removing the vane also in order to clean all the blades. Okay, so since we prepared a slurry soil sample to a particular moisture content, so collect small amount of the soil sample and keep it for oven drying to determine its moisture. So these are different tests for different spring constants. We have the 4 springs. So 4 independent tests have been conducted. So these are the initial and final readings. So this is reference in theta, and this is the conversion from angle of twist to torque. So then G value. So then shear strength value.
Sir,
Yeah.
sir, so means that Vane shear test gives minimum shear strength.
True. It gives the minimum shear strength.
Why, sir?
Because you are conducting a slurry sample. Slurries have a least strength. See, when you talk about UCS and UU, you have compacted the soil sample. But when you talk about the Vane shear, you are taking the slurry. There was no compact. So demonstrably, the compacted samples always exhibit high shear strength as compared with the slurries.
Sir, can you share the video, sir? Due to poor network, I am not able to see.
Yeah, sure. I will share the video. Both
Okay.
the lecture video plus Vane shear video, both I will share it.
Okay.
Okay, very good. So, any other questions?
And sir, UU gives maximum strength.
Not UU. Usually CD will give you the maximum. CD means consolidated drained. Drained means there is no water. No water means dry condition. So dry soil sample always give the highest strength. And this process followed by UU and followed by CD. This hello.